Oh, hey, come on in. Let's go talk about pocket knives. All right, YouTube. Well, before I get into today's video, I want to share some great bit of news with you. I received my first bit of fan mail today. I am so excited over this. So it's a very short letter, so I'm going to read it real quick. Dear Southern Knife Hobbyist, we love your channel. It's so refreshing to find a place on the internet with this great of quality. We always learn so much from your videos. So these are by far the best knife videos on the internet. The only thing that we would change would be that you show your hands quite a lot, but we think you should show your handsome face even more. Wow, I'm blushing, y'all. That is so awesome. And of course, it's signed, Love, Mom and Dad. All right, thanks, guys. I hope you enjoyed today's video. Today's project is the restoral of another Barlow knife. I have a customer who ordered a blue-handled Barlow knife, and they want it to be an EDC or user knife. Now, I've got the perfect candidate for them, a Sabre Barlow, made in Ireland. As you can see, this knife has had a hard life and it's in bad shape, but I've done a similar project before and I know pretty much what to expect. The first thing is to remove these shell handles. Usually you can pry up the little tabs on the end of the knife, but I can't seem to get to these. Instead, after prying around for a bit, I find that these handles unclip from some small tabs that are on the side, then slide up to come off. After that, the construction is almost identical to an imperial. Using a sanding drum, I grind the head off these 3 steel rivets that hold this knife together. The pins don't simply fall out of this one like they do on some shell-handled knives once they're ground off, so I decide to pry the liners off. I take my time and try not to bend them. Disassembly is straightforward. I remove each of the pieces, marking my springs and laying each piece out in the order that it goes. I did not mark my bolster liners, or the 2 side liners. Typically I don't need to because they're normally made such that you can look and tell which is which, but these are made to be identical. The same liner can fit on either side of the knife. This does cause a small problem for me later on, but we'll get to that then. Now, to see what I can do with these bolsters. Obviously, it would be too much trouble to fit handles onto them the way the factory did it. You see, the original plastic handles were molded onto the metal part of these bolsters. So I've got no way to do that, so instead I cut and trim that long tail piece a little shorter. Then I flatten it on my cutler's anvil. My first thought was to try to pin or solder these bolsters back onto the liners and then fit plastic handles on top of them. So I work carefully and try to flatten that piece into a little tab that can be reused in an effort to retain the original bolsters. My biggest problem is trying to get a sharp crease at the handle side or handle end of that bolster. But after working at this for a few minutes, I do a pretty good job of it, but then study the fit, begin thinking about it. I decided to discard these original bolsters and just make my own. I have some scrap pieces of brass that came from an old combination lock. After checking, the smaller one will work. I believe scrap metal looks better on a knife than it does in a landfill. Now this brass is too thick, so I split it with a hacksaw. So laying the old bolster atop the piece of brass, I trace out the pattern. Now there are some flaws in the material that I'll kind of work around and try to avoid and get straight edges. Now I'll take time to flatten the steel liners. The liners have these specially shaped dimples and ridges for the shell handles to use to lock into place onto them. Since the new bolsters and handles will not fit over those ridges, the liners must be flat. After this, I'll work to take out any bows, curves, or warps in the metal. As soon as they're both ready, I prepare to solder the new brass bolsters onto the steel. I'll clamp a piece of aluminum, or aluminium for those of you across the pond, to the liners, as this helps to align the bolsters properly. You see, when soldering the bolsters on, they want to slide and skate around. They don't want to stay in place very well. This helps to hold it, and the solder will not stick to the aluminum. I will begin by tinning the bolster. This means I'll coat one side of it in solder first. Now, here are 4 tips for good soldering. 1. Clean both pieces of metal well. Solder does not stick to dirt, oil, or to oxidation. Secondly, you want to coat the metal in flux where you want the solder to stick. This prevents it from oxidizing while you're heating it. Thirdly, do not try to melt the solder. That's not the goal. Instead, you want to heat the metal piece enough that it will melt the solder. And then fourthly, you want to have something ready to use to drag the solder around to different parts of the metal. The solder will want to follow the heat, but be ready to help it along just a little bit. Now I tin the bolster first as it's thicker and it takes longer to heat. Then I'll flip it over and heat both pieces of metal until the two bond. But once I've cooled the piece in water, I check to be sure that the bolster is correctly aligned. You see, I cut the bolsters to be just a little bit wider and longer than they needed to be, and I'm checking to see that it overlaps all the way around the liner. If it doesn't, I'll have to heat it up and try it again. Now that that one's good, I'll solder the other bolster onto its liner. At first, I had only cleaned the spots on the liners that I intended to solder to, so that I would not get these liners turned around and soldered onto the wrong side. They are rather universal, the two are the same. So now that I've gotten everything soldered onto them, I'll clean up the rest of the liners and all the other remaining parts. As I said before, I made the bolsters a little oversized for these liners. This allows it to be trimmed to fit exactly. So using an 80 grit belt, I roughly sand these until they're almost even with the edge of the liners. I'll go back over them again after assembly to get everything lined up perfectly. I still keep my cup of water handy. Now, I'm not worried about the temper of the metal with these, but I don't want to overheat anything and melt the solder. Now for the handle material. The customer requested blue synthetic handles. I purchased this slab of blue acrylic just for this knife. Now I've already cut the pieces to the correct length and width, and here I am turning the pieces around to different sides, comparing them to the scales to make sure that they line up tightly with the bolsters. If not, I'll sand one edge flush until they do. Now this material is far too thick to fit onto these bolsters well, so I'll also thin out the pieces a bit before gluing them to the handles. Now, I've tried a little experiment with this knife, and it seems to have worked very well. When I use epoxy, I've learned that I have to tint the epoxy with powdered tints, not liquids. Some liquids will keep an epoxy from curing properly. But this Gorilla brand glue is a polyurethane glue, not an epoxy. And it's water activated, so I thought I would try mixing a little paint with it. I have some blue modeling paint on hand that I thought would blend in perfectly with those blue acrylic handles, and this worked great. If anything, the paint mixture allowed the glue to cure faster than normal, and it seems to hold very well. The reason I wanted to color the glue is to prevent any gaps from appearing between the handles and the liners or bolsters. Even the tiniest cracks appear to be magnified once the knife is finished, and this really did help to make those transitions appear seamless. This glue will not only hold the handles on, but it helps to seal away any dirt or moisture from getting between the acrylic and the liners, which can darken the look of the handles or miscolor them or even cause those liners to rust and weaken. Again, note that I coat the end of the acrylic as well, just where it butts up against the bolster. After it is cured, it's time to clean off the excess glue and contour the acrylic to the liners. Next, I'll begin turning these rectangular pieces of brass into rounded bolsters. I begin by sanding a bevel at the top corners at approximately a 30-degree angle. Now I will stop and compare both sides of the bolster and compare the two bolsters together to keep the grind as equal as I can. Once I've done this on the brass, then I'll continue that grind over onto the acrylic. Now I don't try to do both at the same time because the acrylic is so much softer and it sands away faster. If you try to go straight across and get the brass and the acrylic at the same time, it's easy to remove too much material from the handles and ruin them. Once I have a fairly even bevel all the way across, I begin rounding the ends as well. Once I've done this on the platen, then I'll move to the slack part of the belt and make this a smooth rounded transition. It's now time to drill holes and prepare to assemble this knife. But this is where I run into my first big problem. Remember when I said these bolster liners are universal? They're made to be identical and can be flipped around to be either the mark side or front liner or the pile side or back liner. That means they have extra holes for all the pins. Now some holes were used for the front liner, some holes were used for the rear liner. To be sure that I drilled the correct holes in the handle, I compared the handle to the spring and verified that I was drilling in the correct spot. But when it came time to drill for the pivot hole in the bolster, I failed to compare it to that center liner and I drilled the hole in the wrong place. Now, thankfully, a bolster hole is fairly easy to repair though. I learned how to do this on the second knife that I ever repaired. It was the first one that I ever rehandled and I made several mistakes on that knife. But that's a great way to learn how to overcome problems. To repair this, I will peen a brass pin into the hole. Now I don't have to chamfer this hole as I'm peening the brass much harder than normal and the pin will expand with enough force that it will never move. The ratios of brass material or silver nickel material, meaning the amounts of copper, tin, and other metals that they're made from, can vary from one manufacturer to another. That means that sometimes the color of the pin and the color of the bolster can vary enough that those pins are clearly visible. Luckily, the color matches well enough on these, and once I sand both sides flush, the extra pin disappears. Then I simply drill the new hole in the correct place. I've decided not to install the other handle pins. Since this knife does not have a rear bolster, the center pin and the rear pin both go through the handle, and that should hold it sufficiently. On many knives I would also add 1 or 2 handle pins, but for some reason I feel like it would detract from the look of this knife. So after I drill the bolster for the pivot pin, we'll chamfer these holes and begin assembling the knife. If you've watched very many of my videos, you know why we chamfer the holes. We want to give the end of the pins room to expand as I peen them. Now, I've forgotten this step a few times on some knives in the past, and though the knife would look great without it, gaps appear in the knife the first time you try to use it or even sharpen it, because there's nothing holding these sandwiched layers of the knife together. So don't forget to chamfer those holes. The next thing to do is to engrave my name and the date on the pile side liner. After that, I'm ready to begin assembling this knife. I've already turned down the brass pin to the correct diameter, and I've sharpened the end of it to make it easier to insert. Now I'm going to use the same tool that I used on the last knife, the one that I called a spring compressor, because I was never really told a good name for it. The man who showed it to me just said, "You need to make yourself one of these." Great Eastern Cutlery has one, and they call it a witch. Now, there are other tools out there that are already called a spring compressor, and they work differently, so I think I'll begin calling this tool a spring jack instead. But whatever name we call it, I've got this one turned now so you can see it work from a different angle. It works on many different knives, but I feel like I need to make a couple more of them in different sizes. That would suit me better. Unfortunately, I forgot to start recording during the peening process, so I've got no footage of that from either camera. Immediately after peening, though, the blades seemed a little stiff, so I oiled them and worked them back and forth for a bit until they felt right again. For my finishing sanding, I normally start out on the back springs and go all the way around to the back and the front of the knife. After reassembling, there will be microscopic differences in the alignment of each of the parts. Even when I contoured the handle and bolster materials earlier, I left a tiny bit of overlap. So I start off with a 180 grit belt and I keep sanding until all of the parts are perfectly aligned along the back and the ends of the knife. Now, according to the specific knife, this may take longer than you expect. Often I'll look and think I have everything in line, but a more careful inspection under good light will show that a liner is recessed inward slightly or something like that, so I'll keep on sanding. This does take a little material off the back springs too, but that's just part of the process. Then I'll move up to a 400 grit belt and begin to work the rest of the knife, looking for imperfections, areas that need to be smoother or more rounded or whatever. had a few places on the acrylic where I could not seem to get everything to look just exactly the way I wanted it to with the belt sander, so I hand sanded certain spots, especially there at the bolster transitions. Now, this is not something that I have to do with every knife, but I did need to do it on this one. The last step, of course, is polishing. Now, I actually polished this knife a couple of times, as the smooth polished finish will help me find imperfections that I couldn't see when the surface is rougher. I would go back and sand those, come back and polish again, so you may have to do this a couple of times until it's just right. Now, I've had several people ask me to show more of the finished product, so as soon as I was finished with the polisher, I stepped outside the shop building and examined the knife in the bright sunlight. I obviously need to clean the dust and polishing compound from the knife, but I believe the new owner is going to love it, and I hope you do too.